Hi everyone, welcome to today's science video. We're going to talk a little bit about two really cool, important parts of science that apply to our lives every day. And they're really cool and they're fun to do experiments with. So the first thing we're going to talk about are physical and chemical changes. Now those sound like big words at first, but when we simplify it down, it's really cool and easy. So a physical change. When we think of the word physical, we often think of our bodies, or things we can see and touch. Like this marker is a physical object. I can see it and I can touch it. So, when we talk about changes, a change for our purposes today is basically when a substance undergoes an alteration either in its physical form, which we're going to talk about, or its chemical form, which we're also going to talk about. So physical are things we can see. A change that we would be able to see with our eyes without needing a microscope or conducting an experiment or anything like that. So, as an example, in my pocket here, I have some nuts. On this side, I have nuts that are still whole. They haven't been broken or anything. They are still nuts. Over here, when I flip the bag, I have some crushed nuts. Now, they look different. We can see that a change had taken place from the original nut to the crushed nut. However, they are both still nuts. There is not a difference within the nut between both forms being the crushed and the whole nut. Both are the same, even though their shape is different. So that would be a physical change. Physically, nothing has been done to create a chemical change, which is when a new product comes out of what we call a reaction. And a reaction is basically when we put what we call reactants together. You can have multiple reactants, and then they come together by touching to form a new material, which is called a product. Now, a real life example of this could be if you were to pour some, let's say, things that are around the house that we use in cooking, could be vinegar or baking soda. If we bring those two together by pouring them into the same container, they're going to touch and they're going to interact at the molecular level. And molecules, are very small particles that make up a substance. They are the building blocks, and atoms, molecules and atoms, make up everything around us, which is called matter. So, in a chemical change, unlike a physical change, there is a change at the molecular level, and something new is produced in what we call a reaction. A reaction is when we would take, like we said, the vinegar and the baking soda, and something new comes out. Chemical reactions are very difficult to reverse. Now what that means is it's very hard once a chemical reaction takes place to get that substance back to its original state. You would have to go through many more reactions to break up the molecules which are now bonded together. So, how do we know when a chemical change happened? A lot of the time by things like a color change, bubbling, or a change in temperature. Now you may be thinking, why is that not a physical change if there are things we can see? In a physical change, we are taking one kind of substance, or an object, or a liquid, or a gas, and we are keeping it the same. Nothing has changed. It is still the same product, even though it might look different. In a chemical change, that bubbling or that color change or the change in temperature resulted from two or more reactants coming together and then the visible reaction resulted in a change in the reactants in the form of a product. So that's basically physical and chemical changes. They're very cool. We see them a lot in our lives. And okay, so another cool part of science and chemistry that we can see in our daily lives would be through what we call solutions. Now, a solution, everyone has seen a solution before, especially if you've been to the beach, because the ocean is basically a solution. An example of a solution is salt water. A solution, the definition of a solution is a liquid mixture, not a reaction. Like in our last part of the video, when we talked about chemical reactions, a change does not happen in a solution. So for example, in salt water, I have water and I have salt. The water and salt, when they come together, they remain the same. It's still water and salt, even though you see a change, you can't see the salt anymore. So, in a solution, a substance is in the smaller amount is distributed evenly throughout the liquid. So, these are called the solvent and the solute. The solvent is the material in the larger amount, which is normally the liquid or most of the time water, and the solute is present in the smaller amount. So in our example, the solute would be the salt, and the solvent would be the water. So let's actually see what happens when we pour some salt, if you can see that, into water. It's just regular salt here. Pour it in. We stir it. So, as we can see, can't see the salt anymore. It's dissolved inside of this water. So, basically what happens is, because it's being distributed evenly throughout, we can't see it in the clumps like we started out with. But it's still staying the same. So it's actually a physical change if we want to compare it to our last part of the video. So we can measure in chemistry how much of the solute we put in our solvents. So the smaller amount, which is the salt and the water. We would do some math, and we can basically determine how much you would need to make a solution or over make a solution, which is called a supersaturated solution. In a supersaturated solution, you have too much of the solute, and it's more than what the solvent can dissolve, so it doesn't dissolve at all. And we call that concentration, that process of seeing how much solute is contained in a solution. So, thank you for watching, everyone. I hope you learned something new about science and chemistry today. Thanks.